Each.
Yes, ma'am.
Okay. So what we just learned how to solve exponential equations algebraically. That's what you were doing. Okay, using algebra to solve them. Now we're going to see how to solve them on a calculator. Right? And for any equation, and this goes for the tax test or any test you take where you can use a calculator, anytime you have an equals there, you can put your left-hand side in Y1 and your right-hand side in Y2. Okay, so let's do that here. We'll go to y equals, clear anything that's in there. Okay, we're going to put in y1, how are you going to put that in there?
Will you put parentheses?
Yes, you're going to have to put parentheses around the 2x minus 4. So you have 3 rooftop, parentheses, 2x minus 4. Everybody knows where the rooftop is, right?
Yes.
Okay.
Isn't it called carrot or something?
A carrot, yeah. It is called, I don't know why, but it is called a carrot. And then 3 to the second, we go in y2. Everybody got those in? Okay, we're going to solve it using a table and then using a graph. So to go to the table, first of all, I want you to go to second window and make sure your table is starting at 0. Changing the table is 1, and they're both on auto. 0, 1, auto, auto. Okay, and then go to the table, second graph. Okay, and where's the answer? Don't say it, Sean. You know where the answer is, but where do y'all think the answer is? The answer's up here. Where they equal the same, that's right. So where are they equal the same? At x equals 3. Okay? So let's write that down here. X equals 3. Okay, we wanted to see how we put y1 equals y2 here. We wanted to see where y1 was equal to y2, and it was at 3. They're both equal. Okay, so let's check and see if we work this out if we get 3. So how do you work this out algebraically?
2x minus 4 equals 2.
Now why can we do that?
Because the
Because
bases
they're
are the same.
Bases are the same. Good. So then we add 4, and 2x equals
6 and
divide by 2, and what does x equal?
equals
30.
So that worked, didn't it?
Yes.
Okay. Now let's try the graph. I don't like their graph. We're going to do our own graph. Okay. I want you to go to Zoom 6. And from now on, you just have to push graph. But it takes it a while to load it in there. Okay. Which one is y1? Which one is 3 to the 2x? Huh?
The curved one.
The curved one. That's what an exponential looks like. It doesn't actually touch the x-axis. It just comes alongside it down here. And it goes on forever to the left, but it never goes below the x-axis. Okay, this line up here is what?
That's the Y2.
Y2, and what is 3 squared?
9.
9, so it's going right through 9. Okay, to find what they have in common, what do you do? You're trying to find where they're the same, so you're trying to find the intersection.
When
How do
you
you-
use
Do you remember how to find intersection? Second trace or second calc? Which one? 5. Everybody do that. And then enter.
Wait.
What did you get?
9.
3, 9. Which one's the answer? The 3. We're looking for what x is. Okay. So x equals 3. So doing it algebraically, looking at the table, looking at the graph, we get the same answer for all of them. Okay, let's do 2 to the 3x plus 6. And then 8 for y2. It is a 6, isn't it? 3x plus 6. Is that right?
Yes.
Okay. All right. How do we get to the table?
Do you leave that as an 8 or would you?
Yeah, leave it as an 8.
Oh.
No, we're just doing the original equation.
Okay.
Okay, second graph. And what are we looking for?
Whether it's the same Y1 and Y2.
Okay, I don't see anywhere the same here. So let's go.
Is it 8?
No, so what's the answer though?
-1.
-1. Right. It's where they're the same at x equals -1. Okay, and just to show the table, we'll put an X, Y1, Y2, and we can just put -1, 8, and 8. Okay, let's double check it on the graph. Hit graph. Okay, and you remember how to find where they cross?
Second, 3, 5.
-1, 8.
So both ways we got x equals -1. And we'll just sketch the graph. It didn't have to be a big deal here. Okay. Notice how I put an arrow that onto the left, because that's because it keeps going. It gets closer and closer to that axis, but it never touches it. Okay, now you do not have to show the table in the graph. Just want you to find the answer using the calculator. Or let's do this first one, because we're not going to have time to do any of the others.
Do we turn it? Do we put that all on there?
Whoops, I didn't put that right. I am going to put part of this in your journal, so either I can hold on to it or you can hold on to it. You can put it in the box if you want me to hold on to it. Do you see the answer on the table?
-2.
What? They're both what? 0.5? Okay.
Yes.
So you can write x equals -2. But I want you to see what the graph looks like. Let's graph it. Because it's kind of different. Takes forever. Okay. We don't have a straight line on this one going across, do we? That's because we didn't have like a number here, like 3 to the second, which is 9 or 8. Instead, we have 2 exponentials, and they cross, and so you can still do the same thing. Second, trace, 5, enter, enter, enter. And you should get x equals -2. You get that? Okay. All right.
Well, number 8, I don't think it works.
Okay, number 8 doesn't work on the table, does it?
Because
That's because, why would it not be on the table?
it's a fraction.
Yeah, it's a fraction or a decimal. So, to find it, what you have to do is use the graph.
I don't know, it's 2 1/3.
It sure is. That's why it wasn't on the table, because the table's only showing whole numbers right now. So, x equals, you can either write 2 1/3 or 2.3 repeating, okay? Okay, you don't have to do number 9. If you want me to hold on to this, put it in the box. Otherwise, bring it back tomorrow. We might put some things in our journal tomorrow, but that will be all we do, okay? Besides eat. Don't eat too much lunch.
Honestly,
We're not
We're
gonna
not gonna have lunch.
I'm not gonna eat
Right
anything
after. We would get out at 12:45, so.
Oh, you're right, we're not even having lunch.
Yeah,
So
we're
that's
not
I
gonna
forgot.
stuff.
Okay,
So we can eat all we
we can eat everything, yes. What, Michael?
Well, I don't really want to eat anything tomorrow.
You don't have to eat anything if you don't want to.
I just want to eat pie. I just
So what
want
pie?
to eat it,
You don't even want pie?
yeah.
What'd he say?
He said he didn't feel like it.
How do you know you're not gonna feel
We'll see how
like
you
it
feel tomorrow, Michael.
Why don't you feel like it?
You gotta work out after school?
Yeah.
It's if you work out, it's kind
I
of,
got physical therapy.
Oh.
Wouldn't be too good.
yeah. I forgot my name. You forgot what? Oh, your name. Kelsey, do you need to call somebody?
Hey, Mom, I have to
Sure.
stay and take the test.
Okay, can, Milton give me my number? It's not gonna take long. Yeah.
You already did it. So,
Write your
simplify.
Okay, alright.
Alright, bye. Bye, everyone.
But
Are you gonna tell me what discontinuity is?
I did on the computer.
I don't know that.
Discontinuity is anything where there's a break in the graph. So it can be an asymptote or a hole,
Oh.
okay? It can be a vertical asymptote,
So,
a horizontal
what is
asymptote, or a hole.
So for this,
What does it say?
is at what x value assumption is
Do you get a baby gift for
So would that be like, it's asking for that?
I forgot. I couldn't even see when it was. I never can see when it is on my phone, so I never know. Not
I
that
didn't know it till
people
I
live
was
here.
I didn't remember till I went downstairs and I go and see it.
I know. I guess I'm gonna have to get her something later. I'm sorry, Ellie. What it said for what?
Oh wait, never mind, I got
You
it.
got it?
Yeah.
There she is.
I'm almost at 4.
No, I said before.
Yes.
What are we doing? I'm helping you.
I think I might, or I need help with force.
Okay.
I'm saying like,
And I
yeah.
tried.
Wait, so,
I tried to record it and it wouldn't work today. I thought it took me 20 minutes to fix it, and then I couldn't do it anymore. So I thought.
wait, so is this like,
Yeah,
is that
that's
what?
what you're looking for.
Okay.
Okay. There's more than one X value. This is continuous.
Okay. Here's the test.
And you're done?
Yes.
Wow. Fast. Oh, yeah, that's right. You'd already started.
Yeah. I was already on 13.
Yeah.
Well, thank you, Joel.
You're welcome. Thanks for staying and doing it.
No problem. I'm gonna have no life this spring break.
I know.
I'm trying to catch up on everything.
Well, at least you have spring break to catch up.
Yeah. Good thing my teachers are being semi-lenient. Yeah, that's why tomorrow.
How many teachers in the school are having babies?
Well, I'm not.
My cousin is.
Say that. Your cousin is?
Teachers, they're like a smart
I like to thank you. You like to tell people that just for shock factor?
Yeah.
Wait, what? You know the 8th grader is pregnant? It's her cousin.
Oh, she's oh, yeah, I knew
And
that.
she lives with me,
Yeah.
so she's pretty much been like, this is.
Oh wait, I can look these
My
up.
sister was trying to talk about like,
This is probably Bill. I'm trying to run. Hello?
my sister was talking about the
Yeah.
guy that got her pregnant.
Is her friend like here,
but we
Ron?
didn't know that, so my sister was like, she didn't
Yeah.
know she, that he
Because I got a
got
bunch
her
of kids
pregnant.
in my room.
We're like,
If you,
what?
yes,
Yeah, we're like, how do you not
because
have someone
Steve,
pregnant?
Bill, and Evelyn
I know.
all chickened out.
She just didn't know.
All right.
But I'm
Bye.
pretty sure you know how it works if you get, and she was like, no, I mean, Bailey didn't know this guy she had a crush on. So like,
Oh. It's funny.
I was beginning to worry about my sister.
Are you doing 4-7 notes in here too, Taylor? Is that what you're doing?
Yeah.
Well, I have to take this test. Or is it this test?
Do you need 4-7?
When
Yes,
do
I
I
do
need
need
to come
4-7.
in and
Let me
take
just
that
teach
test
4-7
after
to y'all
spring
right
break?
now.
Okay. Yeah, no problem.
If it get rains, if it gets rained out
Yeah.
tomorrow, we'll work on it, okay? Have you done the review? Have you, oh, we already
I
asked you.
started it. Well, I started it by trying doing it without the video. So I have to go to YouTube when I get home and I look the video and do it.
Okay, and the video, or I can load it for you right, or do you have your computer?
I do, but I think it's dead. I think it just died
Okay.
last period.
Can
I take the test tomorrow in class?
yes.
Okay.
You can. Oh, it's on the review, the only part I did were the graphs.
Okay.
And I didn't do the parent graph for signpost, I did a little bit, but I did those other graphs. And so I didn't do like the identities or the,
No, the
Angles.
identities I'm good with.
okay.
Like I know all those by heart.
Good, and y'all know you have to know the double angles, right? Cosine of 2a
Yeah, no, I know those.
and sine of 2a? You know you have to know those? Okay. Okay, so I'll just teach it and I'll record it and I think y'all might be the only two that need it, but I'll have it for next year.
Yeah. Then you don't have to go through all
Except
this.
I gotta find it. Oh yeah, I have an empty one.
Have you been filming like all of them
Mm-hmm.
since day one?
No.
Oh.
Wish I had. No, I just started a couple weeks ago.
Ms. Walton,
Yes, Kelsey?
I have a question about the horizontal axis of,
Okay. You remember how to find it?
I don't even know what that is.
well, I think,
Oh, yeah, I did.
I think I did it, is it like it's at the bottom?
No, that's the.
Ooh, I like her shoes. I like your shoes, Ms. Walton.
You remember the trick for finding the
Ooh, I want that big one.
horizontal?
I know.
Yeah.
I'm like,
See what I can do. I'll give you a review back and you can.
Okay.
All right, more not so simple harmonic motion. I forgot to go. Am I already recording? Oh. Okay. The steamboat problem. Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water surface was a sinusoidal function of time. When its stopwatch read 4 seconds, the point was at its highest, 16 feet above the water surface. The wheel's diameter was 18 feet, and it completed a revolution every 10 seconds. So let's just draw the wheel down here. How tall was the wheel? Oh, did it say? Let's see, the diameter.
Highest at 16 feet.
Yeah, but what was the diameter?
8.
Yeah, 18 feet. So the wheel is 18 feet tall, right? Okay, and the highest point on the wheel is at what?
16.
16 feet. Okay. So, and it's above the water surface. So down here somewhere is the water. We'll call that 0 feet. So the wheel goes how far below the water? If the maximum is at 16 and the diameter of the wheel is 18 feet, how far below the water is it? Down here.
2 feet.
2 feet. Okay, so we're going to do that on this graph. So this would be at -2 feet. And then the tallest point would be at 16 feet. So as the wheel turns, like if you pick a point on the wheel, it turns, it's getting closer and closer to the water surface, and then it's getting underneath the water surface, and down here at the lowest point, it's 2 feet below the water surface.
So it completes one of those every 10 seconds.
Every 10 seconds. And when does it start? Does it say? Well, it says at 4 seconds, what was it?
The highest point.
Okay, so it's at a maximum. So 10 seconds later, which would be, it's at another maximum, because it completes a whole cycle in 10 seconds. Okay?
Wait, so is it sine or cosine?
Well, let's work. If it's going from a maximum to a maximum,
It'd be a cosine.
yes. Even from a minimum to minimum, it's cosine.
So
Okay? All of these have been cosine because we don't ever really start in the middle. Okay? Your lowest point is halfway between. Yeah. And you really don't even have to know where it is on the x-axis. But we do have to find the middle of this. So how far is it from -2 all the way to 16?
18.
18, right? It's the height of the wheel, wouldn't it? Okay. So half of 18 is 9. So your amplitude is 9. Okay?
Oh,
distance
okay, because
between the
whole
two.
distance between the two is 18,
Mhm.
and then you're just looking for half of that. So
Right.
it's 9.
Now we still got to find out where this point is, though, because it's not at 9, is it? If you add -2 plus 9, what do you get? 7. And 7 plus 9 is 16. So 7 is halfway between these two.
Wait, I'm confused. So you do that. You add 9 to the -2?
That's to get,
Or- yeah.
that is to get the K, though.
Yes.
Oh, okay.
Okay?
Wait, didn't we do this on another?
Oh, yeah, we've done it on all,
Okay, let's look.
yeah, on the last 4-6, we did it. Okay.
Well, I could have sworn that there was a simpler thing with K in it.
Maybe. Yeah. Okay, really, this is really the same as what we've been doing. It's just a wheel. We hadn't done a wheel yet.
Okay.
Okay. All right, so I think we're ready to, just about ready. What's the period?
It's like 2 piles of B, but I forgot what B.
Well, B we're gonna find, but the period is how long it takes to go one cycle. So how long does it take to go?
14 seconds.
10.
10 seconds.
So it'd be 2 pi over 10.
Yeah, it says it completes a revolution every 10 seconds.
Oh, okay, so 10 would just work. Okay, sorry.
So B would equal, you're right, 2 pi over 10.
Which would actually be pi over 5.
Right.
Wait, so I'm confused on the. Then why does it go all the way to 14 on the graph?
Because it started at 4.
Oh, okay.
It started at 4 seconds, and I didn't label this like I should have. This should be time and seconds, and this would be feet above water. Actually, it could be below water. Well, it's -2 feet above the water is what they would say. All right, now write an equation. So what's the amplitude? 9. Is it a positive or a negative cosine? Positive. And the B is,
Pi over 5.
okay. You all right with that, Lindsay? Okay. Parentheses, how did it move, right or left?
-4.
Right. Went right 4, so it'd be x minus 4. And then it went up 7.
Wait, now how do we know it went up?
That's this. That's why we found that. That's
So
why
you-
we find it,
So you
because,
don't go by the minimum, that's okay. Like the
No.
minimum.
Yep. You're saying it moved up from the origin
Oh.
7. Okay,
Oh, okay.
okay. Does that help? Okay,
Oh.
now, Go
So that'd be the whole thing moved up 7, which would then put the top at
top at 16 and the
Oh, okay.
bottom at -2. Right. Right. Normally it'd be right here and it would be way down. It would be
Right.
at 9 and 9.
Mhm.
Okay. But since it moved up, it's at -2 and 16.
Okay.
So it's,
Yes, now I have to put that in.
Okay, you got to.
Okay.
is this where the X up there at the top?
Actually, if you have an X minus something in parentheses, you don't. You do it just like this, except you're going to have parentheses like that.
Okay.
That's only when there's not a horizontal translation. If you go ahead and draw your parentheses in your equation, that helps you to put it in there right. Okay. Okay, then it says.
What is your window set on? Because mine is showing that.
First of all, check your mode, make sure it's radians.
Oh, what happened to my Y equals? Wait, go to radians.
Go to mode,
Okay,
make
it's
sure
on.
you're in radians. Okay.
Oh,
And then what would be the window? You just look at your graph and go by your graph. So you could
So-
put it from,
16.
okay, for your X minimum though,
Okay.
we can leave it at -10 or we could change, let's make it -1. So we still see the axis, but, and then your X max goes all the way out at least to 14, but let's go past that, let's go to 20. And then Y minimum, it's down here at -2. So we probably need to go a little lower than -2.
Oh, I got those backwards, so like I was sitting here wondering why. I got it.
Okay, X's are going across, Y's up
Right.
and down. And then Y max has to go to at least
16.
Yeah, so let's
make it
20.
20.
That should graph.
whoa. Oh, I guess that is.
Yeah.
Okay, so that middle cosine right there, that's the one that we have drawn.
Right.
Okay. Then it says 5 seconds. What was the point? Height above the water. So
So
how?
we do value.
Second trace down.
Yes. So it's 14.281 feet above the water surface. Okay, at 17 seconds, same thing. Whoops, I put 7. Why is it doing that?
4.2.
Yes, 4.219 9, I guess, feet above the water surface.
Okay, so
What is the first positive value of time at which the point was at the water surface? So where's the water surface on the graph?
7.
Nope. Look at the wheel. Remember?
Oh, it's 0?
so
It's at 0. So in y equals, in y2, we'll put 0. And graph it. And you can't see it because it's right on the axis. Hello? Okay, you need to ask me next time, okay? All right. Well, you have time. You don't have to be anywhere. Okay. All right, bye.
This won't. You can go ahead and use this as the key.
Okay.
You can go ahead.
All right, I'll do that. She's so confident.
You're only as good as you think you are.
Okay, what is the first positive value? We did this, put 0 in, we're gonna find, it could be right here. If that is to the right of that axis, couldn't it? Okay. So let's do second, trace, intersect, first curve, second curve, and then I'll guess, I'll move it over. Bye. Thanks for doing it. Here's center. And I got .082. Did y'all get that? Okay. So is that positive? It is.
Yeah.
So that's your answer. 0.082 seconds.
At that time, was it
Going Going into or coming out of? Look at your graph.
Oh, so it just means like those 2 points, like, at the x-axis?
Wouldn't it?
Well, it just means right here at this point.
Oh.
Wasn't it coming out?
Yeah, it's coming out of the water, isn't it?
Because if it was going into it, wouldn't it be?
It would be going down into the water. Okay? So it is coming out at that point. Is that, did I answer your question, Lindsay?
Yeah,
Okay.
I was looking at just the middle section.
Oh,
I
okay.
see what you're talking about, because we just did that.
I understand with this with the wheel.
Good.
Wait, what does it say? At what time was it going into it or?
No,
coming
at
out?
that time.
Oh,
At this time right here, at
My
point,
dyslexia just.
yeah, at
Right.
.082 seconds, was it going into or coming? I might have read it that way too.
Yeah, at first, that's what I read.
Yeah.
I didn't understand what it was asking.
Okay, now the next one is something different, but it's not hard at all. This is where, you remember stat edit, stat calc, and you do
Yeah.
linear regression?
Oh gosh, no. I think I remember that whole lesson.
But we're gonna do it, instead of doing linear regression, we're gonna do sine regression. It's all right. So go to stat, press stat, go
Isn't
to
it?
edit.
Does math just keep repeating itself?
Yes. You figured that out. All the rules apply to everything.
Wait, do we put 1 through 12?
We do. January would be 1. Are
I'm
you
done
ready
with
for the
everything.
1?
Yes.
Is it just that 1 or is there more than 1?
It's just that one.
Okay. I think I'm just gonna leave it alone. Is that okay?
Yeah.
Okay.
Okay, do I give it to you?
Yeah.
Okay. I have my review here. Do you want it?
Yes, because I'm giving you extra points for that. So 1 through 12, then you gotta put all those numbers in. Be careful though.
Why did they delay the track meet till?
I think it's supposed to be raining. Bad weather all day tomorrow, really cold.
I don't see why they delayed it for the. I just put it in the junior high today.
Thank you.
You're welcome.
I didn't see why either, Taylor, but I asked Coach Walton, he said that Abilene Wiley and Stephenville canceled.
Oh, okay. So when
They
you did
withdrew,
us-
so
Oh, okay.
we canceled it. They could be
Not
doing
a
it,
good day for the track meeting.
but they could be doing it.
Yeah,
Okay,
I mean, it was freezing like this when we did the one at Mineral Wells.
all right, we entered it in, and find the regression model for the data. But first, let's view a scatter plot. Okay, so y'all have an enter?
Yeah.
All right, go to second y equals where it says stat plot.
Okay.
Push enter for plot 1 and turn it on.
Okay.
And then you're going to go to zoom stat, which is all the way down to number 9. You do that same, anytime you need to do a scatter plot, that's what you do. Okay.
Oh, hold on, let me write that down. Okay, so
Okay, it was,
second y
mm-hmm,
equals then plot on
yes,
and then zoom 9.
zoom 9, yes.
Okay.
Which is zoom stat. So if you forget, you can scroll down until you see zoom stat.
Okay.
Okay. Okay, so what does it look like?
Like this.
Cosine or sine?
Negative.
Yeah.
Looks like a negative cosine. Okay. The only problem is the only regression model we have is sine, but that's okay because the cosine and sine are really the same thing. Okay, so we're going to go to stat calc. So if you want to put stat calc here. And then go down, we have linear regression, quadratic regression, cubic, quartic, another linear, natural logarithm, an exponential, a power, logistic, and sine. All the way down to C.
Wow.
So,
Sine calc and then sine reg
sine reg. Mm-hmm.
or reg.
Push enter. You have to push enter again.
Wait, so press enter and then press enter again.
Uh-huh.
Dang.
Oh, mine's saying quit.
Okay, go back to stat edit.
I already had something on mine, so it's
Oh, how do I get to that edit?
What do you mean you had something on yours?
it
Oh,
it already had a log on there on my screen, and so it makes I don't know.
That
Really makes sense.
edit.
Hello?
Okay, I got it.
Yes. Yes. No, but we will be here tomorrow afternoon. I don't know if you're working tomorrow afternoon. We get out at 1. Okay. Oh, okay. Okay.
Yeah.
We want to just do it next week. Next week we'd have to do it Wednesday, Thursday, or Friday. Well, let's do it.
I like
Thursday
to
or
learn
Friday.
like one thing a week. And
Or
then you just kept
Wednesday,
going
like
over
in the
that and
afternoon,
over
like
and over and
after
over, and
4.
then you got a test, and then you move on to something for another week.
Yeah.
Now it's like every day.
Okay.
Lesson.
Do you want to say like 4:30?
It's like being in Sneals. Were you in Sneals?
That'll be
I
good.
should move to those years.
Oh yeah, that's right. The one.
Yes.
She gave me this paper, and she'd be like, okay. She'd teach
All right.
it to you that day. She
Okay.
said,
Uh-huh.
okay, there.
All right.
And she would give you a turn date. You ask for what it's turn date. Okay, 3 days from now. Yes.
But I'll,
Sorry.
it can be okay. He's,
Okay.
I forget.
We're almost done. Okay. Did y'all get this?
Wait, you said I had.
Did you go to stat edit?
Yeah.
Okay, stat edit.
Oh.
Yeah, you entered it in right. Okay, try again. Do stat, calc, all the way down to 9.
You can see.
Yeah, see, I don't know why I said that. And take your pushing it way too many times. You gotta wait.
I didn't know. Well, it said quit the first time.
Yeah,
I only
okay.
pressed it once. So maybe I should have pressed it.
Maybe so. Okay. Now, we're going to write that equation right here.
Oh, okay.
So for A, we're going to put 16, and we're going to do 3 decimal places, 0.770,
Wait, why is there 16?
because A is 16.770.
Oh, okay,
Okay.
never mind.
Okay. And then sine, parentheses, you've got BX, right? And B is 0.480. X. You okay with that?
No, I'm not really sure. Like I see the
Okay.
numbers on here. Oh, you're just.
I'm
The
filling it in.
equation.
Right, I'm filling
Okay,
it in
I
that
gotcha.
equation there at the top. And that equation looks a little different than our normal equation.
Yeah.
Okay. Plus C, but really,
It's mine.
since C is negative, it'd be minus 1.841.
Plus.
Close your parentheses, plus 66.501.
That's
Okay.
complexity.
It is. Now, these were all the average temperatures in Houston from a year, monthly average. Okay, and it's, well, now we got to graph it. Okay. So, the way we graph it, and all of this information is on your assignment packet. I have to show you that. And that's why we don't have to write it all down because it's in the wrong place.
Is this like legit information?
Oh, it
Or
shows
did
you
they
right
just
here.
make this up?
Mm-hmm. There you go. See?
Okay.
At the end of 4-7, it has it all right there. Okay. So what we're fixing to do next is plug this equation right here into y equals.
Oh
So
boy.
go to y equals and clear y equals. Don't turn your plot off. Leave your plot on. But clear anything in y1 and y2. And then you don't enter it in from here. Okay. We're going to do vars. Okay. Did everybody see vars?
Yes.
Then down to statistics, and that's on the sheet too.
Oh, okay. So
Over to EQ, which stands for equation. And then number 1 is regression equation, which is what we want. So we push enter,
so it does it for you.
and it puts it in. And it puts it in more exact than what we would do.
That's me.
And then graph, and it should draw it through those points.
So it's almost it's
Pretty close, isn't it?
almost exactly.
Mm-hmm. How well does it fit the data? We put awesomely,
Oh,
which is not a word, but we used to do.
Sometimes I wonder if half the actual words are.
Are real words. Okay, then it says, what is the average annual temperature based on the model? Okay, so these are monthly temperatures, all here. So the average annual temperature, you could add all those up, divide by 12, or
Oh, okay.
you could look at the middle. It'd be like in the middle of the graph. Okay, so what we're going to find is where the graph moved up, and that's the K. Okay, and the K is right here. Can't see it.
Oh, okay. Oh,
That-
yeah, because in our equation.
We have the.
Okay.
That's how far it moved up the the cosine graph. So this would be 66.501. Okay, then what is the range of temperatures from the model? The range of temperatures. So we're not getting them from the table, we're getting them from the equation. Okay, and so the range,
Would that be kind of like the period?
well, it'll be close if you're going from here to here. But we're going from here to here.
Okay.
Okay, so from here to here, if we knew the amplitude,
Mm-hmm.
because we know the middle is at 66.50, what's the amplitude?
Oh yeah.
It's the number in front. So you could subtract the amplitude from here, and that would be your very bottom temperature. And then if you add the amplitude to this, that would be your very top temperature. Okay, so let's do that. 66, we go to second quit. Yeah, I did it. 66.501 minus 16.77. So the lowest average temperature is 49.731 degrees. And it ranges from that one to, we'll add the amplitude to the K, 66.501 plus 16.77.
This is all pretty much given to you, besides up here.
Yeah. According to the model, what is the average temperature in September?
you just look on the table.
No, because it's asking for the model, which is that's this equation, which is a little bit different than the table. Okay.
Okay.
Not exactly the same thing. So for that, we just go to graph. And we're looking for September. What month would that be? What? 9. So we'll do second, count, value, 9. So the temperature in September?
76.76.
Right. Okay, and we're not gonna do the last one, you don't need it, okay?
Okay,
Alright.
thank you.
Okay, now, on your homework, you're only doing one